they're so vastly important that I can't skip it, nor would I want to, because I like studying lines. They're way more important than you could ever know. There's people out there all over the place in their jobs using linear functions, maybe more than the other functions. But you're going to be surprised when you get into calculus what a key component linear functions are, and something called linearization and linear approximation. And every now and then, I find that sometimes in Algebra 2, myself or other teachers haven't hit it hard enough. I think I told you honestly, I discovered that last year with my Algebra 2A course. I was going to skip lines, and when something came up about it, I realized, oh, they didn't really understand all the different things about it. I'm trying to make this very literal to you, to where it makes common sense, to where you're not trying to memorize things. Did you get a chance? Did you look at some? I didn't check. Okay. So anyway, jump in if you worked on something that applies. Anyway, as far as like some of you maybe skied over the holidays. I did for a couple of days. And of course, I'm a math teacher, so it's hard for me not to think about slopes when I'm on the slopes. But, I was skiing with my sons, who are faster and stronger and bigger than I am. And they eventually, it's embarrassing. I used to be better than them, and now they're better than me. But they eventually started this game where they're like, Mom, we're just going to lap you. So what we would do is start at the top of like a blue slope, a really long one. And so they would try, while I got down, instead of waiting at me at every turn, they said, we're going to try to go all the way down, come up the lift, and catch you on the way down. But they never did. Okay, so anyway, be that as it may. How many of you ski? Raise your hand. Okay, or have skied. Okay, thanks. But if you ride a bike, it's the same thing. Or you're walking or running in the park, it's all the same thing. We all encounter slopes. Even if you've ridden in a car, you encounter slopes. If you ski it, you're a little bit more intimately involved, because you actually say the word slopes, and use the color a run, or, a blue or a black or a green or whatever. Funny story, it may have happened in this class. It may have. Was it in this class I said, how many of you snow ski? Okay, I said that in another class, and they looked at me like I was crazy. And I realized the look on their face, I was like, oh, okay, because in Mississippi and Tennessee, if you say you're going to ski, that means you're water skiing. Like you're in the warm weather almost all the time. You're on a boat, in a lake, you own some skis, they're in your garage, but they're water skis. So if you go down south and live down south, or like we were just talking about, FedEx is headquartered in Memphis. So down there, if you say you're going skiing, they're going to think you're going water skiing. So we say snow ski, meaning I got to leave the state to go find some snow. Okay? So anyway, here, water skiing, I might have to say water ski if I'm going water skiing. Because if I say skiing, you're going to think I'm in the snow. So anyway, that's just a little side note.
Us Northerners.
Yeah, I like it though. I love the fact that I can just go here. My boys and I were talking about that. It's great. We went to Gore and Wyndham. But I want to go to Stratton next time. What do you think? I've heard it's great.
What's great?
Gore was awesome. I loved it. But we got Hunter and Wyndham on. Okay, so anyway, back. I want to go to Switzerland, actually. That's another story. All right, come back. So the point is, if you ski, then, and some of you probably ski black. There may be some black slopes that are, most everybody raised their hands. So the black slopes are like the most difficult slopes, and then there's double diamonds, which are extremely difficult. There's a couple of times, I don't ski many blacks, I usually ski blues. But there's a couple of times here's my skis. The blacks that I have thought, I got to check that off my list and do that one. There's a few I've looked at and gone, you're looking for the slope. You're like, where's the mountain? Where's the jungle?
Yeah.
Or you're on a blue, and you look back and go, did I read the sign correctly? So, have you ever wondered, am I on the right slope? I thought this was a blue, but this seems very difficult. But anyway, that's going to come up later in class today. But we're going to talk about how how they decide on the difficulty a little bit. I don't know a whole lot about that. Same thing for engineers when they build roads. Actually, it goes along with skiing. In the mountains, many times, if you're watching, whether your parents are driving or you're on some sort of trip with the school on a bus or whatever, you'll see many times this little sign with a truck on it and a steep slope, and like that they even are supposed to go another way. I don't know if anybody have ever seen, there's like a different direction some heavy trucks should go, because if they start going down that slope, which actually in roads they call it a grade, and they actually know exactly at what percentage the slope is to the road. And by the way, even 8% is very steep for cars and trucks to travel on. So you'd be surprised at how almost level a lot of these steep roads are. But even if you've been in a car, you've had that feeling of, where if you're in, I don't know if you know the names of the hills in Central Park, like there's Cat Hill and Harlem Hill, and yeah, well, Harlem Hill's even bigger and taller, but Cat Hill's hard
They
because
made
it's
a sprint up cat.
pretty steep, yeah. So anyway, and so I'll come back to that with like sort of a funny, I don't know if it's a funny story, but I'll give you a story on that. All right, so anyway, just to set the stage for how real this stuff is that we're looking at. All right, now as you're going through school and possibly beyond, depending on what you do, people will give you lines in different forms. And on your worksheet, on your little packet, and you might want to actually write the date January 7th next to December 16th, since it's like the packet I would start the semester with if you're trying to keep them in order now. I need to make sure that no matter where you are, no matter what you do, no matter what class you're in, might not even be a math class that you're having to look at the equation of a line, that you can decipher what's happening, because they might come at you at 3 different forms. You might remember before the break we talked about it, like all the different forms I have to give my name. Like if I'm taking the SAT, I might have to put last name, then first name, and I'm supposed to put Lazari and then Rebecca. Recently I was filling out a form, and I put Rebecca, and I actually go by Becky. I think I told you that. So in a more informal setting, I even have to check and see what form one day that you put my name in Common App, so that I know how to sign my recommendation letter. Because I don't want to sign it as Becky Lazari if you put me in a Common App as Rebecca Lazari, so I need to make sure I'm actually the person that they're looking for. So there's all these different forms that you recognize. Names is one example. There's lots of other things. But I want you to be able to recognize it if it's in slope-intercept form, which is probably all our favorites. So if I have y equals mx plus b, that would be something like y equals 3x plus 4. Super easy to graph this line, okay? What is the y-intercept? Raise your hand. All right, Grazio? Is that right, Grazio? Okay,
Yes.
4. All right, and slope. All right, Yana?
3.
Over, you always need a fraction, so 3 over 1. So from that Grazia said the y-intercept was 4, then Yana and I are going to go up 3 and over 1. And then you could use a straight edge, or you could find a few more points. You can also go down 3 and back 1. Because what if you go down 3 and backwards 1? What's a negative over a negative? Positive. This has a fairly steep slope, and it is going up. Do y'all see the positive slope? Again, I just want to make these things make common sense to you. I love slope-intercept form, okay? I don't actually use it the most, though. I use point-slope form more. Okay, do y'all understand? You don't have to really memorize why this is called slope-intercept form. You're given the slope and the intercept. Do you see? It's not a super fancy name. Okay, you'll use the slope-intercept form the most. Y equals mx plus b until you get to calculus, most likely. Some teachers may, depending on who they are, may switch you over to point-slope form. Point-slope form means all I need is one point and the slope. Okay. And points come at us like X and Y. We might have a lot of points, though, and so we usually a lot of times give them subscripts. Like I might have, this is 0.1, this is 0.2, this would be 0.3. So I can talk about what if you have 2 different points, okay? Point slope form, what do we always call slope? M. And that'll always be true, which is good news, okay? Point slope form is you're going to say y minus your y component, do you see how I'm bringing this down, y minus y? Okay, equals m times x minus, and then you need your x, okay? So this comes down in here. Sorry, I didn't get the whole thing. I think I missed it. This one. All right, so that comes here. And it doesn't really mean you have to use the first point I gave you. If you have 7 points, Margot could use the second one, Sarah could use the 7th one, Daniela could use the 5th one, and your equations might look a little different, but once you rearrange them, they'll all be the same, okay? So an example of that is, let's use some points, and I'll show you an example. And then you'll actually fill out some examples on your packet when we turn the page, but just be patient for right now, and just stay with me. All right, so let's say I have the point 0, 4, and okay, let's say I've got 3 points, okay? So say Rebecca decides to use this point, and she says y minus her y component, which is 4, equals m, which Rebecca and I don't know yet, and this is going to be x minus 0. All right, then suppose that Gabby says, well, I like this point. My lucky number is 13 or something, okay? So she's going to go y minus y equals m times x minus x, okay? And then Evelyn's going to use that point. So she's going to say, I want to say y minus 16 equals m times x minus 4. You know what happened so fast, unfortunately, with that great activity that you did, some of you actually did, kept working on it and turned it in for bonus, the one with the gifts, the soldier in the boat. I really took a while for me to grade them, but what I noticed, the great thing that was happening, that maybe I should even pull that exercise up again, is you could have written different things for me and still gotten to that toy. And so I had to check what you wrote and how you did it. Anyway, now the problem is I don't know the slope of this line. And if I've got it, how many points do you need to find slope? You need at least 2. Does that make sense? You got to have at least 2. If you have 1, watch this. If you have 1 point, there's no telling what that line is doing, right? But if I give you another point, there's no question what that line is doing. What if I gave you another point and you already had this point? Then you absolutely definitely know what that line's slope is. Do y'all see that it draws it that direction? Okay? And so you need 2 points. You could pick any 2 points, all right? Let's suppose that you picked these 2 points right here out of your list of 3 points that you might be given. All right, so on your sheet, and I think that you know it from your other classes actually, is the slope formula. Again, hopefully you memorize it and you understand. Hopefully you memorize it. But also hopefully you understand it, okay? To find out the slope is like this. You want to know how far up and over you're going, okay? This is rise. And for some reason, somebody one day called that run, like running across. Rise over run is your slope. To find out how far you rise, it makes sense to find the difference in your y values. You want to know how far up you went. So I'm going to say 13 minus 4. So I went up 9 units. Do y'all see what I mean? And then across, I want to see how far I have to run across. And so it makes sense for me to subtract my x's. 3 minus 0. So I ran across 3. Hang on just a second, Sarah, I'll get to you. So what's the slope of this line? 3. Okay, Sarah, I haven't forgotten you. Just hang on, okay? Slope is y2 minus y1 over x2 minus x1. Girls, that doesn't really mean you have to say the first point from the second point. It doesn't really mean you have to say second point minus the first point. It just means find 2 points and subtract them. Do y'all see what I mean? So whatever you think is your first point, make sure you put it in the back. Whatever you choose for your second point, make sure you put it at the beginning. That's your slope formula. Hopefully, by the way, when you get into calculus, this is called the difference quotient. What does quotient mean to you? Quotient. Gabby?
The answer to a division.
Thank you. So do you see why it's called a quotient? Because you're dividing. It's also called the difference quotient. I remember hearing my calculus teacher say that. Now I say it all the time, but I didn't realize what they were saying, what he was saying. But y'all see it's a difference quotient. It's a quotient of 2 differences. So therefore you totally memorize it if I say difference quotient. Does that make sense? All right. Y's are rise, x's are run. Everybody okay? All right, now suppose that, Sarah, I haven't forgotten you, okay? Suppose that, say that this was Sarah, and she did 13 minus 4 and 3 minus 0, all right? What if Eliza chose this as her second point and this is her first point? Then Eliza would have said, well, her slope is 4 minus 13, and she'd have had to go back to this point and say 0 minus 3. Eliza would have gotten negative 9 over negative 3. What's her slope? Still 3. Do you see it's okay? All right, what if I had thought, sorry, I don't know which way, I don't know how to get back up. Yeah. Yeah. Oh, there. Okay. Now, suppose that I had liked this point, 0, 4, and 4, 16. I can pick any 2 points I want as long as you tell me on the same line. So I'm going to be in, let's say this blue color here, kind of aqua. I'm going to say 16 minus 4. I'll be really messy up here, sorry. 16 minus 4. And if I start at 16 and go to 4, I come back to this, 4 minus 0. What's 16 minus 4 is 12. 4 minus 0 is 4. What did this student get for their slope? 3. Do you see you could pick your own 2 points? Okay? So what's the slope of each of these people? Each line in this case was 3. You don't have to do all of that for one problem. You pick and choose if you have enough of points. Okay? Sarah.
Oh, you answered it.
I'm sorry. Okay. Did you have a question or a statement? Was it, did I?
No, it was question, but then you answered it.
Okay. All right, Yana?
So I'm just a little bit confused about how you found this. So you find the slope, but you have to use
You need 2 points.
2 points. So
And so if you have 2 points, you're good to go. Just use those 2.
yes.
If you have 10 points, pick any 2 you want.
So then just using the point slope method, how would you solve? Do you again solve for the slope with the point slope?
Yeah. Okay, so let's do this. Let's take our time. Help me remember these points. 0, 4, 3, 13, and 4, 16. Okay. Hope you're remembering them because I might forget them. Okay. All right, so my points are 0, 4, 3, 13, and 4, 16. So say you're on a quiz or a test or homework, and I say, write the equation of the line in point slope form. Okay? So you right now may have to look at your packet until you know point slope form. Point slope form is y minus y equals m times x minus x. By the way, I would reiterate, if you look at the bottom, toward the bottom of your packet, you have this. So I'll just pause for a minute. You have your slope is equal to y2 minus y1 over x2 minus x1. Every student sitting in here has cross multiplied before. I'm going to put this over 1. Have y'all ever done that so you could cross multiply?
Yeah.
Okay, so I'm going to cross multiply. And I get y2 minus y1 equals m times x2 minus x1. And that's how somebody got the point slope formula. They just rearranged the slope formula. It's nothing new. But do y'all see what they did with the letters X and Y? You really want to say Y minus one of your Y's. M, X minus one of your X's is what that means. But it's really just the slope formula. Do you see if I divide by this again? I'm back to my what I called my difference quotient. Okay, I didn't know that at your age, but I thought I was learning something new. It's just the slope formula. Somebody slapped the X's on the other side.
Right.
All right? I felt really silly for memorizing it. Gotcha?
So the difference quotient is that y minus.
Y over X minus X.
Okay.
The difference quotient is this M equals rise over run. So next to Y2 minus Y1 over X2 minus X1, that's what your future teachers, in a few years when you're in calculus, they'll call that the difference quotient.
Okay.
But do you see how the words make sense, Grazia? Because you're taking the difference and then the quotient. Okay? All right, now back to this. Y'all ready? See if I can get back down there. Okay. All right, so let me write my point slope form again. How are you going to remember which one's the point slope form? You need a point, which means you're going to say y minus your y and m times x minus your x. Okay? Let's say that you're on a test or you see a graph and you know for some reason you have these 3 points. Okay? So watch how this works. Ella, pick a point, any point from the list of these 3.
4.
All right, so Ella's going to go, I'm on my quiz, so I'm going to say y minus the y, m times x minus the x. But now what does Ella need to find to finish this off? Her slope. So what's Ella going to have to do? How's she going to find her slope? Daniela, what do we need to find our slope?
The point.
All right, we need not only the point that she chose, but don't we need another point to see where it went?
Yeah.
So you always need 2 points to find the slope, but I hope that makes perfect sense, even if you're taking notes. Remember how I drew this dot?
Yes.
All right, and you would need another dot to know the slope. Do y'all see what I mean? Another dot is going to tell you your slope. So I think Ella would probably just choose, she probably use the point she already has chosen and maybe pick another one. Okay? So let's find the slope. We're going to do it in our heads right now. I think we already all know what it is, but okay. I don't suggest doing it in your head, by the way, but we're going to do it right now. 16 minus 13 is 3, and 4 minus 3.
1.
So we already knew our slope was 3. So Ella, check mark, go on with her life. She got that right. Okay? All right, Margot, pick one of the other 2 points.
4. 16.
Oh, that's the one Ella picked.
0. 4.
All right, 0, 4. All right, so Margot's going to go, I'm on my quiz. Y minus y equals m times x minus x. I left a blank because right now we're pretending like Margot's just started and she doesn't know the slope. Okay? How many points does Margot need for slope? 2. So she's going to use the one she got already, the one she chose, and combine it with another one. It doesn't matter which one. Let's use this one. Okay? So then Margot goes, oh, I need another point. Okay? By the way, let's time out for a minute. If there's actually already a graph given, you actually could still count out your rise over run. That's fine too. There's so many different things to talk about with lines. All right, so Margot's going to go 13 minus 4. In our heads, that's 9. And 3 minus 0 is 3. And what's Margot's slope? 3. Okay? Both of those are right. Both of those are right. All right, now let me show you what, you may not have noticed what I did here. A good way to check it, or for me to show you that they're both right, is to get it in slope-intercept form. Right now it's in point-slope form. Do y'all see it's in point-slope form? I want to get it in slope-intercept form, which we'll do on our sheets in a minute. In order to get, I'll do this one in yellow. In order to get this one in slope-intercept form, I'm going to say y minus 16 equals, watch this, 3x minus 12. And then I just distributed, then I'm going to add 16. And I get y is equal to 3x, what?
So we're trying to find slope intercept
Okay, this is point slope form, and this is slope intercept form.
Slope intercept. And
Okay.
right now we're letting slope intercept. Or both. Or we have
I'm
to-
just showing you something right now,
Oh,
okay? So far today, I did slope intercept, and then I did point slope, but now I'm just showing you something interesting.
okay.
So now I'm just talking.
Okay.
All right, but everybody should be looking because it's extremely interesting, okay? Not really, but still watch. So if I do this one, I'm going to get y minus 4 equals 3x minus 0. So I don't really need to write anything down there. And then I'm going to add 4. Some of you have realized what just happened. Okay? So this one was Ella's. This one was Margot's. But maybe you didn't realize I was actually still working on this one. We're at the point 0, 4. And with the point, where'd my points go? Did I erase them? I erased them. 3, 13. If I go out 3 and up 13, do you see it would also land there? And I think 4, 16 was another one. So I sneakily picked some points that were on this line that I had already done. All right, so the reason I had to do that is in calculus, lots of times, almost always, I know the slope and a point. I don't want to do all that other junk. All that other junk is only finding slope, but I don't want to. If somebody gives me slope and gives me a point, which I know that sounds weird right now, you may think, why would they do that in calculus? But that's a whole nother story. So by the time my girls get to a certain part of the problem in AP Calculus, they already know the slope, and they already have at least one point. And so do you see why they prefer this equation? They have everything they need. They put in the point, they put in the slope, they're done. But if it's multiple choice or if they have to check their answer in the back of the book, guess how that answer is written most of the time is in slope-intercept form. So as time goes by in here, if you need to check an answer on something that I give you, and your answer is in point-slope form, and you look at their answer and it's in slope-intercept form, shouldn't yours change into theirs?
Yeah.
Okay? Anything you picked over here was going to turn into that answer. All of these lines that go through those points should have the same slope and the same y-intercept. Okay? All right, questions before I move on? Okay?
So once you fill in everything in the point slope form.
Yeah.
And then you solve it, so like.
Oh, well, wait a minute. I'm just showing you things. I mean, you'll be given directions and know where to stop. So right now, I'm not saying you need to do all of that. I'm talking about slope, I'm talking about forms, I'm showing you that this was right and this was right, or, you know, they all end up at the same place. But what will happen on some of your what will happen on the test, when I say write it in point slope form, I'll have to check yours individually because they might look different. But say you run out of the room and you wanted to talk to your friend, what did you get for number 7? Suppose you got this and your friend got that. If you remembered what you wrote down, you could distribute, rearrange it, and what should happen, you should both get the same slope-intercept form. Okay? So you'll know on a quiz or test where to stop, or if I don't say, you could pick. Sometimes that's what my calculus girls get to do on my test, if it's what's called an FRQ or free response. They, or DBQ, there's all kind of things that people throw around on AP tests. But if it's open-ended, and I just say write the equation of the line and I don't specify, they can write whatever form they want to. Okay? It comes up more in multiple choice because suppose I wrote this form and I don't see that in my multiple choice, I have to know how to change it. And there's one word we're going to talk about. Any other questions or comments before I move on? Ella?
Can I go to the bathroom?
Yes. Okay. So now we're going to take this and put it in standard form. You can look up on Khan Academy, Purple Math, Math Bits, different Algebra 2 math books, and find a different standard form. Do y'all see the third one right here? Sometimes, it's fairly consistent, but I see some variations sometimes. And so I'm going to go with the one I gave you because this is the most common. Just don't get all upset if somebody gives you a slightly different variation of it. Just kind of go with the flow. The only other variations might be they have the C on the other side and they set it equal to 0. But these are the normal rules. The normal rules to get it in what's called standard form, ax plus by equals c. Do y'all see where I am on the front page of your packet? That's the least helpful, okay? I just don't hardly know anything when I look at that. If it looks kind of nice, like you might have 2x minus 4y equals 7. I don't know anything about it. I don't know the slope. I don't know the y-intercept. I don't even know any points. Like, I don't like this one, okay? But it's kind of common. And they call it standard form. It's sort of like, you know, your name, and you've got to give your whole entire name. It's sort of the more formal one, okay? Standard form, here's the rules. You don't want any fractions. You want to have all integers. And this lead coefficient, the one in the front, we call that the lead coefficient, has to be positive. Sometimes the rules vary from book to book. That's what we're doing by in here. So if you want to draw an arrow to A, and it's got to be positive. So what's going to happen if you want to check your answer? I'm sorry, if you want to get your answer in standard form. All right, let's suppose that we're back to this line that I sneakily chose today. I've done that a few different times in a few different ways. Did y'all realize that? Okay. Now, suppose that all of a sudden you look at your multiple choice and they've got it in standard form. ax plus by equals c. That means the x's and y's are all on the same side. Okay? That's all that means. So do y'all see I'm going to subtract 3x to the other side? Y'all see that? So it's going to give me negative 3x plus y equals 4. The x has to be in the front, the y has to be in the second, and the number has to be on the other side. But what did I say the lead coefficient had to be positive? So what can I multiply on both sides by? I can multiply by a negative. I don't even write that down actually though. I just multiply through by a negative and do it in my head, but I got to be careful that I don't do too much confusion with you. If I multiply both, okay, first of all, time out. Isn't it algebraically only okay to multiply one side by -1 if I do the other side by -1?
Yeah.
Okay. All right, so what's a negative times a negative? That gives me 3x minus y equals -4. That's in standard form. So far, I have these things going on. Okay, now I'm going to go to Desmos. All right, and I'm going to type in the three things with the check marks by them. 3x minus y equals -4. What's going to happen when I type in all three? Jillian?
You get a line.
Yeah, I'll get a line. Anything more specific? 3x minus y equals -4. Okay. Now I'm going to type in y equals 3x plus 4. And then I'm going to type in y minus y from the other slide. I'm just trying to remember what I had there, equals 3 times x minus 4. Do y'all remember where I said people could pick their own point? All right, when I turn the green off, you see blue. When I turn the blue off, what do you see? Red. They're all different forms of the same line. It's just Lazzari, comma, Becky, Lazzari, comma, Rebecca, Rebecca, Lazzari. You know, I really don't ever have the conversation with somebody. There's actually a person employed at this school, I won't name their name, but they can't decide what to call me. Some days they call me Rebecca and sometimes they call me Becky. I don't think they can decide. And I answer to both. But I'm still the same person. They're not going to go, oh my gosh, I thought you were Rebecca Lazzari, but you're Becky Lazzari. That's so weird. Okay? Go ahead.
So they're all different forms of the same line?
Yes. All right, so on this whole page, that's what that's about, what Daniela just said. These are different forms that can come at you. Girls, make it as easy as when you pick up a quote form. Do y'all hear that word? a form to fill out, I have to pause and go, do they want last name first name last? Do they want my middle initial for the airlines? You know, I have to abide by whatever form they've asked me to do with my name. Same with the line. Does that make sense? There are 3 different ways, probably more, to write my name. Okay? All right, so let's go to the second page. And let's fill in some. You'll be doing the rest of I hate to say this, because I'm so scared you won't listen to me. For students of your caliber, once I tell you what your homework is, then you'll start on that instead of listen to me. What I meant by students of your caliber, y'all have been such a great class, and you work so fast. I'm so scared to tell you that your homework is to finish the worksheet, but please don't try to do it now. Please stay with me.
This
Yeah.
worksheet right
I
here.
don't get it.
Okay, stay with
She
me.
said I already
Did you
tried.
already do it?
No,
Oh.
I did it. I already did it.
I attempted. I couldn't do it.
Okay, all right.
I did the whole thing. I understand.
Okay, well, but you're going to listen and make sure you're okay. All right? Did y'all have a reindeer on yours, or did I just draw a reindeer on mine?
It's like a little corn. I keep drawing.
Did I do that? I must have done that.
I saw it. I did not know. Oh yeah, that's all reindeer.
There's a reindeer on mine. Apparently I was being kind of cute. There's a reindeer. Okay.
Thank you.
Yeah. When I pulled it out to get ready for class, I'm like, did I put a reindeer on there? All right. It's in pink on mine, so I must have done it. All right, shh, girls, do not work ahead, please. You'll be sorry, I promise, okay? And that, not that I'll be mad at you, you'll be sorry because all of a sudden you'll get to a section you won't know what to do if you've had your head buried trying to finish your homework, okay? So let's do number 1 together. Number 1, all right, raise your hand if you can tell me what form this line is in. Your choices are slope-intercept, point slope, or standard. I saw Sarah's hand first. This is in standard form, okay? Sarah and I and the rest of you couldn't just out and out graph this. I would have to mess with it for a while. In fact, girls, many times to graph these, people want to do what I'm instructed to do right here. Hey, if I said right now graph this, you'd have to sit down and make a little XY chart and find at least a couple of points, which would work. Or we could do this. The instruction, John, and this is what I was saying, write the slope-intercept form, which is y equals mx plus b. Girls, the slope-intercept form, you want to totally solve for y. So to solve for y, I'm going to subtract 3x. Those of you that can move faster and do things in your head, I'm okay with. Just be careful. Negative 2y. You want your x next to the equals. Do you see how you have a negative 16 and a negative 3x here? They're not like terms. Please write your x next to the equals. Why? Because you're trying for y equals mx plus b. Now to solve for y, I'm going to divide by negative 2. You could be writing this down and you'll have number 1 done.
Yes.
So that gives me y is equal to 3 halves x plus 8. Make sure the x is, don't do this. The x is not supposed to be on the bottom, okay? That's a big deal that you won't understand right now. But the x needs to be out there by itself or with the 3. All right, is everybody okay so far, Daniela?
Why did you begin by subtracting 3 and then you're dividing by -2?
Okay, let's do it over. All right, so Daniela, I'm shooting for y equals mx plus b, right? All right, so that tells me it's a lot like if you came in today and I said instead of math, we're going to make fun things with the markers. So I'm going to go red, orange, green. And so then you're going to go red, orange, green, okay? I'm saying you're going to go to y equals mx plus b. So the first thing you need to see is a y. So you need to want to leave that. You want one of these over here on the left-hand side. Okay, which I guess, is that your left-hand side? All right. So you want a y all by itself. So that's why I got rid of this. Okay? Now, I think some of y'all are ready for what I'm about to do. To me, that's a little more confusing than just doing it like this. I'm going to move this over here. So I'm going to say negative 2y. To move this over here, I have to subtract it. Did a lot of y'all understand what I just did here?
Oh, yeah.
Okay. I mean, I don't know if that looks better to you than saying negative 3x to both sides. But to actually get this to the other side, I need to subtract it.
How do you know it's a negative?
That's why I was afraid I would lose you, so I didn't do it. But if I had 3 plus x equals 7, how are we going to solve for x, Bailey?
I would subtract 3.
Yeah, so we're doing the same thing.
But you can't subtract 3.
Okay, so I could actually do this, or as we get older, we usually just go, oh, I need to subtract 3. Okay, so
So that's why it's a negative?
yeah, you're going to see some, what if I had, don't write the, or you could flip over somewhere and write it somewhere else, but this is not on your worksheet, but this will happen to you. Suppose you have negative 4x plus 7y equals 8. No, this is not a number on your sheet.
It's an example.
Yeah, I'm sorry to interrupt you. Is that what you're going to ask?
Yeah.
This is not a number on your sheet. I'm just answering some questions that Danielle and Bailey had, which everybody will also have, okay? This will happen to you what's under the 2020. Are y'all watching? Okay. I want to leave 7y over here by itself. And so I want to move the what?
The x.
Say it what it is.
So
Negative 4x. How do you move a negative 4x to the other side, Gracia? You add it. So this would be 7y equals 4x plus 8. In the old days, which may be the same days you're in right now, it's okay with me if you physically write that down. To get rid of a negative 4x, you need a positive 4x. So that gives me 7y equals 4x plus 8. But I think a lot of you might even do better just knowing if it's positive, because negative on the other side. In fact, watch this. Yana, don't forget what your question is. Hang on. Everybody watch, even if you didn't have that question. What if I had 3 plus 4 equals 7? Do y'all agree with that? That is true. Okay? Would it be true that 3 is equal to 7 minus 4?
No. It is?
It is.
Right. How did I get that 4 to the other side?
You subtracted it.
It was plus 4, so how did I move it? Would y'all agree that 4 is 7 minus 3? Okay. Would y'all agree that 5 minus 1 is 4? Would you agree that 5 is equal to 1 plus 4? Do you see what I'm doing here? It was a 5 minus 1. How did I move the 1 over? I added it. All I'm doing is skipping this step where you got to go plus 1 plus 1. I'm doing it in my head, but to me it makes more sense. I'm not forcing you to do that. I just thought maybe you'd understand it a little bit better. All right, I'm sorry, I kind of cut off some people. Comments, questions, Jana?
So, in the first example, the 3x minus 2x equals to negative 16, why did you put the negative 3x in front of the 16?
This is what I was telling Daniela. You're looking to put it in this form.
Yeah.
You want your y completely by itself on the left-hand side equals, what's next to the equal sign? Mx. That needs to be next to the equal sign. So when I subtracted the 3x, I didn't want to put it back here, I wanted to put it right here. This is going to go over here somewhere. Okay? So it's like this.
And it would still be the same answer though? Because
If I said, can y'all see these? I want a green marker here and then orange red. Okay? And then I hand you some markers. Okay? So over here on this side, we have green, orange, red. And you go, oh, well, Miss Lazeri wants the green all by itself. Sorry, girls, can y'all kind of see? Miss Lazeri wants the green marker all by itself. So I'm going to move these two over here. Okay? Done. Is that done? Did she follow my pattern? Where do I want the orange one?
On the other side.
On the other side. This is y equals mx plus b. You want the x right next to the equals. Okay? So if you're trying to, you want to move this x over here. You want to have a y, an x, and a number. A y, did y'all see that?
Yeah.
Okay. So let's start over. So Danielle, I'm finally going to answer your question. I'm going to leave this negative 2y because I'm starting to get, like, if we even have blues here. I can't think of a good way to do this with these silly markers that I've started on, okay? But if you had all of this, first thing I might do is probably move these and then move the blue one. I don't know if that makes sense or not. Probably not, but I think I've overdone the markers. I want the y by itself, but I've got to just do a little bit at a time. I want to move the 3x. It's a positive on the left-hand side, so what's it going to be on the right-hand side? A negative 3x. Do you want it before the negative 16 or after? This has got to stay here. I want the x to be next, negative 3x, and then negative 16 kind of scoots over to make room for it. Okay? So it's sort of like I moved the red marker to make room for the orange marker. Okay? We okay so far? Now look at your pattern. You want y completely by itself. So the first thing you do is get rid of the x, move it on the other side next to the equals, and then solve completely for y. So now what's in the way is the negative 2. Isn't it multiplied? So what are you going to do? Divide. All right, so I'm going to divide this side by negative 2. And I also do have to divide everything on that side by negative 2. If you divide one thing by negative 2, you better divide everything by negative 2. Okay? It's just like with your siblings, where you go, that's not fair. What if you had a bunch of money and somebody came and took $2 away from you? Because they're like, we're going to buy pizza tonight for the family, but you're all going to donate $2, but they only take $2 from you. You would go, that's not fair. You need to take $2 from her and her and her, right? So divide everything by negative 2. What's negative 2 over negative 2 cancels, and you get y. A negative over negative is a positive 3/2 x. And what's this? A negative 16 over a negative 2. Positive 8. Now do I have y equals mx plus b? So all these questions are awesome, okay? So you made me clarify and keep them coming, because sometimes I take too much for granted. I want a y, I want an m, I want an x, and I want a b. You'll get it to where you're used to the pattern. Do I have that, girls? Do I have a y equals an m? Now I can see it more clearly. It's just like I put glasses on your head when you were looking kind of fuzzy. I don't know how to graph that one. Like, I really don't. I could figure it out in a few minutes, but I don't know how to graph that one. But isn't this the same one, just in a different form?
Yeah.
What's the y-intercept? 8. Y equals mx plus b. So the y-intercept is 1, 2, 3, 4, 5, 6, 7, 8. And then how do I get to my other point? Rise over run. Rise 3 and run 2. So I'm going to go up 1, 2, 3 and over 2, put another dot, and that's that same line. Okay? I think everybody knows. In Desmos, I could put this in y1 and this in y2, and what would happen? Good. It'd be the same. All right, Bailey?
So if we were taking a test and like you didn't specify what form, you would accept any form?
Yes,
Okay.
and that will happen some. And when we do the function art project, where I think a lot of y'all have seen that coloring book that the other classes have made, I'm not going to care what form it's in, because you'll want some lines in your project, and so you could write whatever you want. You have a little bit more control of your own destiny, and y equals mx plus b. That's what most of you, if not all of you, chose to get the toys on the Christmas extra quiz grade. Okay, let's do number 2. All right, number 2 is 13x minus 11y equals negative 12. All right, I'm going to write it in different colors so that I can manage it. Okay? Which color stays on the left if you're trying to get slope-intercept form? Let's write it down. All right, which color stays where it is? Margot? The red.
How come the red?
Because when we're using y.
I don't know whose voice that was. Whose voice? How come the red?
Susan.
Susan. Okay, do you see how it says y equals?
Yeah.
So you're trying to get y by itself.
Oh, okay.
And so you're moving everything out of the way,
Yeah.
okay? It's like if you had a really messy room, okay? Obviously, this maybe happened to me sometime, but this happened yesterday. Where are my running shoes? Like, where did I put them? Got in from a ski trip late Sunday night, had to go to work and pack my running clothes Monday morning because we had to come to work yesterday and you didn't have to come to school. And so I actually have my suitcase is blown up in my room when I'm looking for things. But in order to find my running shoes, I knew they were probably in the corner of my room, but you see I had to move some of my stuff off of it first. So right now you're looking for your running shoes, okay? So your running shoes are Y. Right now you're just moving everything away from it. You're clearing some space. What color is the easiest one to move first? What color do you need to move next? Or I haven't even moved anything. All right, I'm going to keep the red over here. I want to move the 13X. I want to move the yellow. Now, if I'm actually going to put it on the other side, what is it on the left-hand side is positive. What is it going to appear on the right-hand side? Where do I want it? Okay. So I'm going to actually take this negative 12 and scoot it out some. Okay? So that I can put this negative 13x right there.
Right.
And then what's your last step? You want to solve for y. Divide by
Equal by -11.
negative 11. You'll get really ugly answers, okay? Y is equal to 13 over 11x minus 12 over 11. A really ugly answer. But a little bit easier to work with,
Right.
okay? All right. Question?
For dividing by -12, don't you divide it by -11?
Oh, sorry. Thank you, Jillian. Look at my mistake here. Thanks. I divided these two by negative 11, but not that one. So, Jillian, when this one be positive. Okay. Thanks. All right. So let's do one more. Let's go down and do number.
Because your hands are soft and mine are hard, so they just sound weird.
Let's do number 6. Number 6 is 4x minus y equals 1. Okay, so as Susan was clarifying, I want y left behind. Right now, what kind of y is it? All right, negative y is equal to, what are you going to move? The 4x. Where are you going to put it?
In front of the 1.
In front of the 1. Very good. And then, what are you going to do now?
I
Gabby?
have a quick question.
Okay.
Is there a problem if you were to, on the top level of that question, just flip the y?
No, I would do that. Thank you. You're welcome to do that.
Thank you.
So I'll get there. I would do that. I'm glad you brought it up. I need to say that at some point, but I didn't want to lose other people, so I'll say that
And
next.
doing the work is important. I'm
Yes.
just really lazy.
No, that's really efficient. It's an interesting concept. Girls, Gabby sees an easier way to do this that I will mention. I just want to do it the same way every time at first. But if you've got want to use some critical thinking skills, sometimes you can get there faster, and I would do actually what Gabby said that I'll share with you in a minute. She said she's really lazy, and what's funny is it's really efficient. And that's what really good mathematicians are. That's why people hire you one day if you're really good at math, because they know that you'll do it the best way, the quickest way. Over time, you learn all those critical thinking skills. Okay, she may have actually done it because she feels like she's lazy, but I find it very efficient. Let's keep going. Negative y. What's understood to be in front of the y if it's not there? 1. So I'm going to divide everything by negative 1. Jillian, I got my negative in every place that time. So you have y is equal to 4x minus 1. This is a negative over a negative. which is 1y, 4, and minus 1. And then you could graph it, right? All right, so I've done number 6 also. Let me show you what Gabby did. And there's a lot of you in here that want to do this also. Right now I'm just trying to be consistent. So if you feel like what I'm about to tell you will mess you up, just don't listen, okay? You could plug your ears up and go, I can't hear you, but don't say anything, okay? Those of you that really like an easier, more efficient way, watch what Gabby did, okay? Ella, I would maybe watch and see if you like this, okay? Gabby's got the sense to know that she wants y by itself. She also assumes, but she asked just to be sure, that I really don't care which side it's on. It's just got to be by itself. So she saw I could just shoot this y over here. It's a negative y, so Gabby added it to the other side. And where's she going to put this 1? Over here. Isn't it the same answer? Shouldn't I accept that answer?
Indeed.
Okay. Yeah, those are right. Okay? Yeah. Those are right.
I thought this is a trick question.
No, it's not a trick question. If you have x equals 4 or 4 equals x, it's the same statement. Okay? So let me give you one to try. Suppose you have 3x minus 2y equals 8. Don't try it. Do it with me. I tell you what, don't even write this down. Okay? Right. But also just think about it. Girls over here on the right, y'all watch. It's not always going to be negative, the y part. If it is, though, a lot of times I do what Gabby did. I'll go ahead and put the 2y over here and put the 8 over here. Do you see how I added 2y to this side and subtracted 8 to that side? Now all I have to do is divide by 2. I still have to divide everything by 2. Okay? But most of you are probably still going to do this. You're going to leave the y over here. I'm going to put the 3x over here and leave the 8 and then divide by negative 2. All right, now let's hurry up and do number 9. Scroll, look down at number 9. Number 9, you have a point 1, 2, and a slope of 7. Girls, I really need y'all to be quiet and pay attention. Number 9, you have a point 1, 2, and a slope of 7. All right, write the standard form of the equation. But first of all, what form is easiest to start with here? Point, slope. Margot and I have a point and the slope, so I'm going to go to point slope form. Okay, do y'all see what I mean? I have a point and the slope, so it kind of makes sense what form I'm going to. I'm going to go to y minus y equals m times x minus x. Do y'all see what I just did there? Y minus y equals m times x minus x. But now they ask for it in standard form. So Yana, back to what I was telling you, they'll tell you what they want, okay? Is this in standard form? No, it's not. First thing I'm going to do is distribute. Y minus 2 equals 7x minus 7. And Gabby, there's other ways you could do this, which will be fine. Just, I'll look at your homework or something if you're doing it a different way. The rest of you, that's also true. Right now, though, let's look at our pattern. AX plus BY equals C. So where do I want that 7x? In the very front of the other side, right? Now, if I'm going to move it to the other side, it's not going to be a 7x anymore. What's it going to be? Negative 7x plus y minus 2 equals negative 7. Now what do I need to move? You want ax plus by equals c. I have ax. I want to move that 2, don't I? Over there with the other number. It's a minus 2, so what do? Plus 2. So I have negative 7x plus y. If I add 2, I get negative 5. And then what did I tell you about the lead coefficient? You want the lead coefficient to be what? Positive. So if it's positive, the quick way to do this is just change all the signs. 7x minus y equals 5. What I just did was I multiplied both sides by -1 in my head.
Magical.
Okay? That would change that to a positive and that to a negative and that to a positive.
Yeah.
So spend some time just on this page. You do not have to do the next page. Oh, I'm sorry. I'll post it, but you'll go through number 16.
Okay.
You do not have to do 17 through 24 yet. Okay? You'll be doing 1 through 16.
Wait, read this.
Yana, question?
Yes. I was just wondering,